Hey guys, this is the final video for this school year. This is Unit 9 review video. So I am going to do some problems from our review worksheet. I picked some out ahead of time, and also I want to cut some problems out because of the nature of e-learning. We did kind of cut out some things from certain sections, and I think we cut out a couple sections altogether. So because of that, I do not want you guys to do these problems. I am going to post this in Schoology, but again, you don't have to do numbers 4 to 6, 9 to 11, and 21 to 24. Everything else that's on this review sheet will in some way show up on the test. Okay, so it's definitely important that you understand how to do the other problems other than these ones that we're cutting out. I will post that on Schoology so that you don't have to memorize or come back to the video. All right, starting with number 2, when I have a system of equations and two lines that are graphed, the solution is the point of intersection, right? So this point, we always write the solution as an ordered pair, is negative 5, comma, 5, so that's the answer. And one thing to note is that for number 3, for example, if I have parallel lines, okay, two lines that have the same slope are parallel, those would be no solution because obviously parallel lines never intersect, right? So since they never intersect, there is no solution because the solution is the point where lines do intersect. All right, so those are just kind of quick warm-up problems. Moving on, I'm next going to do number 8. Okay, so for number 8, it says, given the ordered pair, decide if it's a solution, yes or no. There's two ways to go about this. I could try to solve the system using elimination or substitution and then see if this is the answer. But a way that might be a little quicker is by plugging in. Okay, so if I plug in my x value to be 3 and my y value to be 27, I can check to see if I get a true statement. So for example, negative 4 times 3, okay, because x is 3, plus 27 equals 15. Let's see if that's true. We get negative 12 plus 27 equals 15, and sure enough, that is a true statement. But I'm not done yet because I cannot just check one equation. I have to check both equations, right? So here we get x is 3, so 3 minus 3 times 27 equals negative 12. I kind of have a bad feeling about this one. All right, let's see. 3 times 27 is 81. So we get 3 minus 81 equals negative 12. And obviously that's not true, okay? 3 minus 81 is negative 78, which does not equal negative 12, which means this is not a solution. It does not matter that the first equation worked. In order for the ordered pair to be a solution, it has to work in both equations. So the answer to this one is no. You'll try number 7 on your own. Okay, let's do a graphing one, a substitution one, and then a couple eliminations. And maybe we'll do 20. And then I'll do a couple word problems with you. So again, I'm moving fast, but you can always go back and rewatch. Okay, so let's start with this equation. These are in y equals mx plus b form, right? So my slope is 3. My y-intercept is negative 3. So negative 3 is my y-intercept, and my slope is 3, or 3 over 1. So I'm going to go up 1, 2, 3, right 1. Up 1, 2, 3, right 1. And I like to draw as many points as I can because at one of these points, the graphs should intersect. So there's my nice straight line. Okay, and then in orange, I'm going to do the second one. So this slope is negative 1. I'm going to put it over 1. This y-intercept is positive 5. Okay, so down 1, right 1. Down 1, right 1. And now I can see where these are going to intersect. So I'll draw a couple extra points, but I don't need to do all of them because I already found that point of intersection. And that point of intersection is the solution. So the solution is the point 2, 3. That's the answer. All right, that's the first way to solve a system. The second way to solve a system is using something called substitution, okay? So what we're going to do is notice that in the second equation, this y is isolated, okay? It's by itself. What that means is that this entire expression is equivalent to y, and therefore, in my other equation, I can replace y with that equivalent expression, okay? So that's why it's called substitution. I'm going to plug it in. So I'm going to rewrite the first equation, negative 3x plus, instead of writing y, I'm going to replace it with this entire thing, 2x minus 11, because that is what y is equivalent to. Okay, equals negative 16. So I just finished writing out that first equation, and I'm going to solve. 3x or negative 3x and 2x is negative x minus 11 equals negative 16. Add 11 over. We get negative x equals negative 5, and then divide over that negative symbol, or it's the same as dividing by negative 1. So I get x equals positive 5. Now I'm not done, because in a system of equations, I need to solve for x and I need to solve for y. So I get to pick either equation, the first or the second, and plug back in to find the other letter. I am going to choose the second equation. I think it'll be easier to plug into. It's 2x minus 11. Instead of x, I'm going to put in 5. Why? Because that's what x is equal to. Minus 11. So I get y equals 10 minus 11, which is negative 1. Okay, and I want your final answer to be written like an ordered pair. So the final answer is x is 5, y is negative 1, so 5, negative 1. And that is our substitution method. I'm not going to do all of 16, but keep in mind that for 16, you need to get one of the y's by itself, whether it be this one or this one. I probably would get that second y by itself by dividing everything by 2. So that's just kind of a hint on how to start that one. But I don't want to take up too much of your time. Moving on, I'm going to do some elimination problems. I'll do 17 and 20. 17 is super quick because if I line this up like a big addition problem, you're going to see that those y's cancel out immediately. Positive y, negative y, those cancel out. I'm just going to add everything up and down. So 3x and negative 2x is just x, and negative 10 and 8 is negative 2. I'm already done solving for x. That's pretty sweet. And then I get to choose which one I think I want to plug into. I'm randomly selecting the first one to plug into. So 3x, I'm going to replace the x with negative 2 because that's what it equals, plus y equals negative 10, and now I'm solving for y. Okay, so negative 6 plus y equals negative 10, and then add the 6 over, and I get y equals negative 4, and I'm done. So this solution, final answer, is negative 2, negative 4. Bada bing, bada boom. Let's do a harder one. Looking at number 20, unfortunately, nothing's going to cancel out easily here, right? So in order to make things cancel, I have to do some multiplication. Let's see. I'm deciding to get rid of my y values, okay? And the reason I'm doing that is because one of them is positive and one of them is negative. So I don't have to worry about changing the signs. I know that one's positive and one's negative, so I can get things to cancel after I'm done multiplying, okay? Now, the trick is to multiply by the opposite number. What I mean by that is 4 and 3, we need to figure out a number that they both go into, and that number is going to be 12, right? 4 times 3 will give me 12, so I'm going to multiply my first equation by 3. for my second equation, 3 times 4 will give me 12. So I'm going to multiply my second equation by 4. So that's what I mean by you kind of multiply by the opposite number. Notice like I multiplied the second equation by 4 and the first equation by 3. So you can kind of flip-flop those numbers. Just make sure that you multiply the entire equation, right? So 3 times 3 is going to give me 9x plus 12y. And I'm going to need a calculator. You guys know me and my mental math. It ain't so pretty. 28 times 3 is 84. Okay, so I also multiplied this number. And now I'm going to multiply through for the second equation. 4 times 2 is 8x. Minus 4 times 3 is 12y. And I can do this one in my head, negative 16. Okay, so now, since I did this successfully, the y's do cancel. They go away. So I get a 17x, because 9 plus 8 is 17, equals 68. And I'm going to divide over that 17. So I get x equals 4. Now, I'm not done. And again, this is the most grueling type of problem you're going to come across. So if it seems long, it's because it is. It doesn't matter which we plug into. I'm going to plug into the second equation. No particular reason. It just looked easier to me. So 2 times x, which is 4, minus 3y equals negative 4. So 8 minus 3y equals negative 4. Subtract over 8. Negative 3y equals negative 12. And now divide over the negative 3. So y equals 4. Which means my final answer is 4, 4. Okay. Just a couple word problems. I might quickly talk about piecewise, but I know you guys just did that, so hopefully you don't need too much, and then we'll be done. The types of problems I put on the test are like a number problem and then like something with money, okay? So these are the two that you're going to want to worry about. So for example, number 25, 3 times a number plus a second number is 55. So 3 times a number, so let's do 3x, plus a second number. So it's a different number, so let's call it y, equals 55. There's my first equation. Okay, second equation. The difference of the first and second number is 5. Difference means to subtract. So if I'm taking the first number and subtracting the second number, I get 5. There's my second equation. And then it says find the numbers. This looks like a really good problem to do elimination because it looks like my y's are just going to cancel out, which they will. So I get 4x equals 60 and divide over the 4. I'll show all my work. So x is 15. So that's the first number. So to find the second number, I'm just going to plug in. And it does not matter which equation I plug into, so I'm just going to plug in x minus y equals 5. So 15 minus y equals 5. A lot of you can just do that in your head. 15 minus what is 5? The answer is going to be 10. I'm going to subtract over the 15 if I want to show all my work. So negative y equals negative 10, so y is 10. All right, so the second number is 10. Perfect. Okay, and then finally, last one. Fast food restaurant sells cheeseburgers for $3.25 and french fries for $2.85. Raquel and her friends bought 6 total items for a total of $18.70. All right, so guys, when we do these problems, I want 2 different types of equations. I want one that has all the money involved, and then I want one that's talking about the total amount. The total amount problem will always be x plus y, or the total amount equation will always be x plus y equals however many items total. And they told us that they bought 6 total items. So it's x plus y equals 6. So let's just say cheeseburgers is x, French fries is y. So if I add them together, there's a total of 6 items. Now the money equation, we just put all the dollars with the variables. So since cheeseburgers, which we said is x, is $3.25 each, we'll do 325x. French fries is $2.85. And that's going to equal the total amount of dollars, which is $18.70. Okay, so there's my 2 equations. This is definitely harder to solve. I wouldn't freak out, you guys. Personally, I think I would do a substitution to solve. So to do that, I'm just going to get one of the letters by itself. So y equals 6 minus x. And then I'm going to substitute this in for y into the other equation. So it is difficult, but you have a calculator. So 325x plus 285 times 6 minus x. Instead of y, I just replaced the y with 6 minus x equals 1870. Okay. Next step is going to be to distribute the 285. I'm going to need a calculator for that. So I have my calculator right here. So 285 times 6 is 17.1. So 325x plus 17.1 minus 2.85x. Okay, so I distribute it to the x as well. Equals 1870. We're almost there. Okay, let's combine 325 minus 285. 3.25 minus 2.85 is 0.4. So 0.4x plus 17.1 equals 18.70. And, you know, I know decimals can be scary, but don't overthink this. Don't overthink it. We're just solving a normal equation here. 0.4x equals 18.70 minus 17.1. I guess I could do that in my head, but I'm using a calc because why not? Let's divide both sides by 0.4. We get x equals 4. You should get whole numbers for these problems because you're not going to get like 1.5 cheeseburgers, right? We said cheeseburgers was x, so there's 4 cheeseburgers. We had 6 total items, which means we have to have 2 French fries. And that's the deal. All right, guys, so I did a lot of your worksheet for you. Go back, finish the problems that I didn't do. In terms of the piecewise, just like really quickly, one of the biggest things to keep in mind is for these breaks, you always go to the filled in circle, right? So the one that says g of -4, the answer is going to be 1 because that's where the circle is filled in. And then for this one, wherever, basically, I mean, I don't know how the video that you guys saw explained it, but the way I think of it is there's 2 categories here. There's the equation for x is less than 0 and the equation for x is greater. So since this number is greater than 0, it's going to be plugged into the orange equation, right? So I'm going to plug in 4 times 1, which is 4, plus 10 is 14. So that's the answer. Now for the actual breaking point, 0, both of these have a 0. So which one do I plug into? The one that's underlined. So I'm going to plug into the red. So 3 times 0 minus 2 is 0 minus 2. There's a crying baby coming upstairs, so I apologize for that. But good thing I'm done with my video. Okay, so that's the deal. Go ahead and finish the worksheet and check your answer key and use it to help you on the test. Good luck, guys.